Mary Butwin, and I'm here to tell you about my master's thesis that I completed here at the Atmospheric Sciences Department at the University of Alaska Fairbanks. Here in interior Alaska, the fire season starts in the beginning of April and extends through the end of August. During this time, an average of 1 million of acres of land burn. The biomass burning releases large amounts of trace gases and aerosols into the atmosphere. The release of these pollutants lowers air quality, which can also be problematic for those living in the area. There can also be lasting ecological effects after deposition. Tracing the transport of wildfire plumes is extremely difficult in Alaska as the fire season coincides with the cloudy season, making the use of satellites such as Calypso extremely limited as the LiDAR cannot penetrate through thick cloud layers. However, with the use of unmanned aerial vehicles or UAVs, not only can the plumes be detected and traced, but chemical concentrations can also be measured. Before a field project using UAVs is conducted, it is important to know at which height, direction, and speed the UAV should fly. To do this, I used simulations from WRF-Chem for the Crazy Mountain complex of fires that occurred near Circle, Alaska in August of 2009. I then created a flight simulation for a UAV traveling through the fire plume. The flight simulation extracted the meteorological and chemical quantities at a specific location, time based on the UAV's position given the flight pattern and speed. Based off of the simulated flights, I found that the UAV accurately picks up on environmental lapse rates as well as the diurnal cycle for temperature and dew point temperature. When dealing with chemical species, it's important to consider whether they are photochemically reactive or if they are a product of photochemical reactions. For example, during the hours when the sun is low in the sky, the production of nitric oxide decreased or stopped altogether because of the lack of photolytic reactions. The flight simulations indicate that considering the speed of the UAV as well as the flight pattern is important factors to consider as they dictate when the meteorological and chemical sensors will be at a certain location. Simulating flight paths using model data would be extremely useful when planning field campaigns, as it will not only save time but also money.